Hello everyone, let's solve this problem LeetCode349. Okay, so we just talked about the solution of a brute force algorithm, and also we use a hash set. So we can also solve this problem use another algorithm. Let's say we can use a sort with binary search. Okay, the third algorithm for this one, we can sort it, use sort plus binary search. Okay, so for the sort binary search, how do we do for this problem? Let's give an example. So basically what we do, so first we will choose the shorter one. So we will compare numbers 1, numbers 2, which one shorter, this one shorter, and then we sort the shorter one, let's say the numbers 1, and then after we sort it, and then we iterating the numbers 2 every single element. So we do a binary search. Let's say. So we do a binary search. Actually, we will search from the numbers 1. We search the target. So we iterating this one. So I equals to 0. So inside of the numbers 2, the element 9. This is the target. We will search it from the numbers 1. We use the binary search. Okay, and then we at plus we search numbers 4 in this numbers 2, and then we search we do a binary search again for the target 9 in the numbers 2, and then we do the binary search again for the numbers 8, and we search numbers 4 we search target 4 in the numbers 1. So when we do search, we use binary search. This is basically the algorithm. Okay, so for the let's start coding. I don't know what this one. Yeah, this is the one we just did, and then what we do, we just copy here. We delete this part. Okay, so for this one, what we do first, we do the same thing. We do the corner case. We check numbers 1 equals to none, and numbers 2 equals to none. And then what we do, we just return none. We just return none. Okay, this is basically the algorithm. And if numbers 1 the length greater numbers 2 the length, and then what we do, we just int temp equals to numbers 1 and numbers 1. So basically what we do here, we are compare the numbers 1 and the numbers 2. So which one shorter or smaller? So we put it numbers 1. We get the numbers 1 is a shorter one. So if we don't do this step, it's also fun. We do this step just for saving the space complexity array. So first we're gonna sort the shorter one, the smaller size one. This numbers 1. Okay, after we sort it, so we new in set. The name is intersections, and then this new hash set. Okay, we are going to use this to store our result in this hash set. So what we do, we iterate every single element in the numbers 2. smaller numbers to the length I plus plus. And then what we do here, if array star, and then we do binary search for the numbers 1. We are searching the target, the elements in this numbers 1. Inside numbers 1, we are searching the target numbers 2 atom I, okay? And then if this one we do this, if this one greater minus 1, that means we found the target. If we found the target, then what we do, we just add it to the hash set here. Add the numbers 2 inside the intersections. And then after the for loop, what we do, we just return. Here is the intersections, the stream. This is Java 8. Okay, map to int the to array. Okay, so basically what we do here, this is the streams. So we are trying to actually convert the hash set, here is map, to integer int here. Okay, here is to array. If you are not familiar about this method, you can just always Google the map to int stream. Okay, this is Java 8. Okay, it's looks a little bit like, if you're not familiar, looks a little bit weird, but yeah. Okay, let's run the code. Here has something wrong here. Come from the single intersection. Oh, here is wrong. Sorry about that. Intersections. Okay, let's run the code. Written intersections, the cannot from the stream, here no s. Okay, let's do this. Okay, accept. So the time complexity for this problem, let's talk about the time complexity for this problem. Is gonna be O(n) here, O(n) log n plus m log n. Because we are searching the target in the numbers 1, the size of numbers 1 is n smaller than m. And then we iterating every single element in the numbers 2. So the time complexity for this part is gonna be m log n, and this part is n log n. So that's why the time complexity will be m log n plus n log n. So the space complexity gonna be, 1 second, we just do this. Okay, the space complexity will be O1 because we don't have an extra hash set. We don't have an extra space. Okay, we do have a hash set. Oh, not this one here. So we do have a hash set here, intersection, but we are trying to store the result to the intersection. That's why this one is not extra space. Okay, so we are talking about extra space. So for this solution, the extra space is gonna be O1. Okay, I'm gonna talk more about it. So next video, I'm going to talk about we are going to use sort plus 2 pointer to solve this problem. It's also very kind of like the space complexity also is O1, and the time complexity is similar with this one. Okay, let's run the code. Our algorithm is faster than 11% for Java Online submission. Okay, thank you for watching. I'll see you next time.